Let's start with. Okay, so I think I basically, first of all, like, who has questions? I guess all of you. You can leave your microphones on, guys. It's not that noisy, I guess. Okay. So, what I'll do is I'll quickly try to like go through this presentation, which explains stuff about the framework and the things we are trying to do. Gives like a big highlight of where your GSoC project is gonna fit in, and then I'll jump into talking a bit about like the GSoC timeline, the proposal, and the tasks that you guys have been working on. And at any point, just feel free to stop me and ask if you have any question about anything. Yeah. Okay. Okay. So, is someone asking anything? Gabriel? Ah, okay. So you mean the Puppet dev kit? Okay. Okay, let's do this. Let me like solve your queries first, and then we can jump into the presentation and stuff, so that we make sure like we have spent enough time on answering your questions. Okay. Okay. Yeah. 3 gigabytes. Yeah. Yeah. Which mount? CE mount? Yeah. Ah, okay. Are you doing everything as root? Ah, you're on Windows, so okay. That's the issue, man. Uh, so like these containers run as privileged, because like they kind of use like some low-level Linux kernel functionalities. So you need C groups, and Docker on Windows does not. Uh, I know. Yeah, yeah, yeah. Which one? Which one? The config master or the basic config master? Oh, don't worry about config master. You don't need config master. You only need basic config master. So you can ignore the config master container for your task. Okay. If everything else is working, then it's fine. Okay. Any other? Yeah, yeah. Ah, yeah. Ah, that's interesting. Which, like generally installing Docker is pretty straightforward. Uh, did you configure, yeah, what version? of Docker have you installed? Okay, if it's 18.09, then it's good. And when you mean by your internet stops working, you mean the internet on the host machine? Okay. Ah, that's an interesting one. Yeah, yeah. Okay. Sure. Yeah, that's fine with me. That would be more helpful to take a look. But worst case, just as a backup, do you have any VMs on AWS or DigitalOcean or anything? Okay. If you sign up on, do you have a Amazon EC2 account? No? Okay, so that's perfect. So basically, no, that's fine. I think it might save you this time. So essentially, if you go to Amazon EC2 and you sign up, the first time you sign up, you get a free account for 1 year, and you can host up to you can host pretty decent machines over here. So I would recommend that you sign up. Yeah. So what it will give you is it will give you like a clean virtual machine in which you can install Docker and you can do your task at least. Yeah. Sure. Yeah, sure. No worries. Okay. Hey, Mickey, are you there on the call? Yes, I can hear you. How are you doing? So far, so good. Okay. Any questions that I can address as I pull requests? I just have to review one of them in the compiler, but it looks good. Okay, cool. Uh, okay. So, any other questions, guys? Yeah, yeah. Okay, semantics.py, I have to say, is like the easiest use case that you will get. Wait, this is not the compiler. Let me open it up. So, uh, so in semantics.py, essentially what's happening is, so the way this compiler is working is that like in the first three phases, we just do text manipulation, move things around, download different like default value files, and then try to put it in such a sequence that when you parse it through like a regular YAML parser, which is the PyYAML parser, it returns like a Python dict which makes sense. And semantics.py is essentially running PyYAML uh, to to be able to like convert it uh, to be able to convert this modified text file into a Python dict. So that's essentially check YAML syntax. So every time you run this compiler, there will be like this temp folder which gets populated. So the yeah so yeah, so it will contain like all the default files from the repositories, the main default file, and then some of the files that it generates during the stages. Uh, Essentially, if I go here, this is like the main function which is controlling this execution and phases. Wait, not this one. It's in here. So the main function. So you've got phase one, phase two, phase three, four, five, six, going like in the sequence, and like the output of one phase is like the input of the next. So they are kind of chained. So for semantics.py, I think that comes in, I can quickly check, should be. phase 4, yeah. So you can take this phase 3 output. The phase 3 output, I think, is it's either expanded. I can quickly check it for you right now. So if I okay, so we want phase 3 output dot name. So phase 3 output is essentially this runtime.yaml file is what you get an input and you try to generate an output. Uh, if we are just opening this file, the runtime.yaml. Uh, this is our output file, and then we do a yaml.dump. Okay. Uh, Actually, now that I think about it, there's not much to test because this function is already uh, like this function from PyYAML, the ru sorry, is already like I've seen it being tested before. But what we could do is we can always test something. Uh, so here, what I want to make sure, so we can, this would not be like a unit test. This would sound something like a unit test combined with a integration test, kind of integration of like the previous phases. So this is the file that you're giving in as input, right? So one thing that you can test is if runtime variables. So the idea always is that runtime variables should be present on top of the file because then they are used somewhere later in the file. So you can check. So if the runtime variables, so you can create a test case where in the file runtime variables are somewhere not on the top, like in different positions, and see if you get like a if PyYAML can convert it into a YAML or if it throws an error. So the first time where they are used, so for example, this variable, I can find where it's being used. So basically, if run any runtime variable declaration is below here, it's gonna fail uh, because it's being used before it's being declared. And the problem of so there's like one of these phases is essentially I think in lexemes.py we are essentially extracting runtime variables and moving them on top of the file because by default these variables are specified by like the person writing the site level config file in his input, and then all this meta info and defaults are appended on top of the file. So runtime variables by design end up being used before they are declared. So that's why it's important to push them up. So I think that's one thing you can test if we should get an error, but for future it would be good in case something changes this order. Okay, sure. Okay, where did our browser go? Yeah. So, any other question from you guys? Okay. So if there are no questions, then I'll just jump in uh, to the presentation, give you some idea about the project. Okay. So essentially, so at CERN, you might already have some idea that we have the largest particle accelerator in the world. So it's called the LHC or the Large Hadron Collider. It's like this 27-kilometer long tunnel running across the borders of France and Switzerland, and particle beams from opposite directions essentially collide. And from these collisions, there are like millions of sensors which are collecting data. Uh, and that gives us essentially about 50 plus petabytes of raw data every year. On top of that, we have around 80 plus petabytes of simulated data. So there's a lot of stuff, like a lot of computing power, which is required. So last I checked, we were using around 600K CPU cores around the world. And like scientists from around the world are submitting what we call jobs to analyze this data, process this data. And the thing is, like CERN at in-house can only provide up to 20 to 30% of the CPU and storage. For the rest of it, for of this like 50 petabytes and 80 petabytes of data, we rely on this thing called the Worldwide LHC Computing Grid, or the WLCG. So the WLCG is essentially a collaboration of around 170 computing centers around the world, spread over like 35 plus countries, and it's organized in terms of like tiers. So essentially, we've got like this big tier zero center at CERN. So this is where all the raw data from all these collisions arrives first. Then there are like 14 tier one centers, which basically means that these computing centers have pledged to CERN a specific amount of resources and uptimes in signed contracts, and they provide it every month, every day. And then there are smaller centers which you see around the corner, which are these tier two centers. So they're not as big as tier ones or tier zero, but they're slightly smaller and have slightly lesser responsibilities. And then there are like several tier threes. You could actually be a tier three if you install something called Boink on your computer. Then you can also start processing these jobs from CERN. So I think we can. I already discussed this. So essentially, this is the design of the grid. There are a lot of computing centers around the world that need to work together so that, like, the scientist who's sitting somewhere in the world, when he sends in a request for, I want to process data from 2012, early morning, proton run, or something like that, we are able to coordinate where those files are stored around the world, fetch them, then find a suitable computer around the world where it can be run, and then run their analysis, generate the output, and then return the output back to the physicist. So this is what the WLCG is doing in like a 30-second nutshell. So in order to make all of this happen, there's a lot of like middleware packages and services which are required to be installed at these grid sites. So some of them are listed on this left side of my screen. Guys, by the way, please feel free to stop me if you think I'm going too fast, or if you are not understanding anything, or if you want me to skip something and move forward. So let's keep it interactive. Okay. So some of these, yeah. So some of these grid packages are so basically from the project's perspective, we need to think about three things, which is compute elements, batch systems, and worker nodes. So Arc, for example, here is a compute element. Condor has a compute element and a batch system, and the worker nodes can be based on it as well. And then the one that we are currently using is called Cream. So if I go back to our main repository, you will see a repository for Cream, which is this one. So this basically houses a compute element and a batch system in a Docker file, which is here. Okay, moving back to the presentation. So essentially, there are a lot of options among these compute elements and batch systems, which means that there are a lot of ways in which you could set up one of these 170 plus data centers in the correct configuration. The thing is that like the grid was developed like several years ago, more than 15 years ago, And back then, we did not have software like Docker, Kubernetes, Puppet, Ansible, OpenStack. Uh, so a lot of it was built in-house back then. A lot of the middleware software were built in-house. But the thing is, now that we've come 15 years forward in time, we actually have a lot of technology available around us that we can use to simplify the task of running these data centers, setting up and maintaining these data centers. So this is where like the root use case of the framework arrives, and this we also confirmed in one of the surveys which is on this site. So simple, if you went through like the specification, essentially stands for solution for installation, management, and provisioning of lightweight elements. And the big goal is that it should be able to set up any infrastructure with minimal oversight and operational effort. So we are trying to automate a lot of the processes involved in setting up and maintaining such data centers. So this project was started like about a year and a half ago, but like the idea of it has floated around for 3 to 4 years. So when we started, so I come from a open source background myself, so I wanted to set up some principles that we stick to uh, in order to ensure that this framework can be scalable in the future. And what we discovered by sticking to these principles that it can actually go beyond the WLCG and can do any sort of complex deployment, which I'll discuss in a bit as well. So these principles you might have already heard of it, so I'll just like speak one line about them and we can move on. So abstraction basically means that we try to abstract all the low-level details related to the configuration of different services and packages from the site admin and only expose things which are absolutely necessary for them to provide. But at the same time, we provide mechanisms for them to like override and get into like a advanced mode to attain the configuration that they want. Uh, so for this, Docker clearly provides a big layer of abstraction, and then in the compiler, if I still have it somewhere, yeah. And then in the compiler, you see all these default files coming around, which further help reduce the configuration that a site administrator has to type himself in order to set things up. The next one is dry, which is don't repeat yourself. It's pretty common in software development these days, and we wanted to make sure that we can somewhat remain dry in this framework. So leveraging YAML is a big advantage in that because YAML 1.2 specification comes with things like anchors, which is essentially like a variable, and with some modification to these anchors, which we do in the compiler, we can attain a pretty dry environment. The next one is modularity. So as a complete picture, like everything in this framework is pretty modular. So we've got like a core part of the framework which contains certain modules like the compiler, the configuration validation engine, and this Puppet module, which is also present in the main GitHub repository. And then we have things like component repositories. So like this is the component repository for Cream, and we can essentially have any type of component repository to keep adding support to this to a particular compute element or a batch system without modifying any other module in the system. The next one is simple deployment. So Docker, Kubernetes, Docker Swarm, anything that we find that can simplify the deployment process. The idea is to be able to use that. Uh, this one over here is one node to configure the site. So essentially, these data centers can get pretty big. So we do not want a site admin to go from one machine to the other in order to uh, like configure their nodes individually. So the idea is that they just select one node in their system, which we call the config master node, and that config master node will use SSH or Puppet or Ansible in order to configure all of the remaining nodes in the system. And the last one is extensibility and community efforts. So the idea was always to be open source so that support for different modules can be added by experts from those technologies. And so far, it's been going all right, I guess. Okay. So essentially, what this simple grid project does is that you write like 100 lines of YAML, which you can, I think there's a file in the compiler called complete config. So essentially, you write a file like this, which describes your site, the infrastructure that you have available, and like the things you want to install on that infrastructure. And then you execute the framework, and then the framework takes care of setting everything up on all of the nodes. So, yeah, so like I was mentioning earlier, we took these abstraction, modularity, and extensibility too seriously. So initially, like this project started from the grid use case, but we've come to realize that you can use it for any type of deployment outside of the grid use case as well. So we have a student who will be coming here next week who is creating a Apache Spark cluster for her economics or finance related jobs that she wants to submit on the cluster. There can be applications in IoT, AI, machine learning, anything that needs like a configuration at a larger scale. So this framework essentially combines configuration management tools like Puppet or Ansible with container orchestrators like Kubernetes and Docker Swarm. So it gives you like the best of both worlds. So it allows you to like get very specific with what you want in your configuration and how and makes the system very replicable. So you can move your configuration from one place to another easily. So the idea is that you focus more time on what you're trying to develop rather than setting up your machines in the right way. So like I said, there are three core components: the YAML compiler, the validation engine, and this Puppet module. And the compiler and the validation engine are completely Python based. So the goal right now is that we develop like a very robust core through GSoC and through like working through it together. And we can test it in the grid use case with all this scary amounts of data. So we know like we built a really robust system and then we can expose it to other applications with ease. So that's like the big level overview of what this framework is, how it came into picture. So in the next few slides, I'm gonna discuss a bit about uh, basically the design and the architecture uh, that we follow. So the framework has this top level specification document, which is essentially this Google Doc that we are trying to write to describe how everything works, and then then we can have like different implementations based on like whatever technology we want to use of the specifications. And the idea is that this specification should boil down the process of reaching a successful grid sites into sensible steps. And then you can have different parallel implementations of the specification, which can give you different uh, grid sites or different combinations of the logical technologies that you need to be part of the WLCG. So there are a couple of so because it's modular, so we have like several elements. that you've already seen the compiler and validation engine. Uh, it describes this central configuration manager, which we are writing in Puppet and Ansible. So I guess the second project in GSoC is about writing this central configuration manager in Ansible, and there was some work done on it last year by Tarang, who was also the GSoC student last year. Then we have these things called component repositories. So you can see one of them here for Cream, and we have another one for PBS, uh, which is right here. And then we'll have more in the coming months. So these are the component repositories, and the site level configuration file, which you just saw, is also another component of the framework. So the site level config file, as I discussed earlier, basically is one place where one of these system administrators describes what they have available at the sites and what they want to install at their sites. Uh, Then the component repositories are essentially like Dockerized services that the framework can instantiate at scale. So they are right now just hosted on GitHub like regular repositories. So they've got like some meta files like this config schema.yaml, the default data which contains the default values, and also, if you're curious, it also gets downloaded here, all the default values in the compiler, and some meta info which describes this component to the framework. Uh, by which, if I try to be a bit more specific, which describes this component repository to the Puppet module to tell it how to set up firewall, some other like file systems, and how to start its container. Okay, so that's a quick overview of the component repositories. Then we have the YAML compiler. So you guys are already working on it. So, uh, so it builds on top of PyYAML and RuYAML. By default, you can override you can like declare variables or YAML anchors. Uh, we insert default values in the compiler. So that allows you to use a lot of default values in your site level configuration. YAML allows you to override anchors, and that's present by design in the compiler. Uh, and there's a keyword called include besides the keyword called from. I think I'm discussing it somewhere, maybe, maybe not. Okay, yeah, here. So there are like two new keywords that we use. One of them is from, which basically overcomes a limitation of YAML, where you cannot do anchor to anchor assignments. And then there's this second keyword called include, which is like a import in Python. So you can split your file here, this config file, into several smaller parts and then just do a include for all of them. With the help of the validation engine, which I think you'll come to see as you work on the issues, it's possible to declare custom data types for which you can have custom validators and schema files. And then the default values come from the compiler, uh, which fetches it from these repositories that we have online. So like this compiler plus the config validation engine gives you like a lot of functionality that you can use to remain dry, as in do not repeat yourself, and abstract a lot of configuration requirements of a big cluster and reduce everything into a super small file. Does it make sense until now, guys? Yep. Okay. Okay, perfect. Perfect. So then we have this central configuration manager. Right now, there's one which is written in Puppet. Uh, So I can show that to you as well in case you're curious. Um, Simple grid puppet module here. So the secret about this repository is that everything is in the master or the issue 27 branch. So we have 239 commits here and it's pretty actively being developed. So this is the central configuration manager and it essentially calls your compiler, calls your validation engine. It implements like a big part of this sequence that we specify, like all the stages that we specify in the specification here, and all these functions that we say execute hooks and callbacks and a lot of things which you'll read here. So all these stages are essentially controlled by this Puppet module. So you'll see this process site level configuration file, validate site level configuration file are essentially the YAML compiler and the config validation engine. And then we use this Puppet module to call the YAML compiler and the config validation engine. And then it does the rest of the deployment testing and cleanup parts in later stages. But you don't have to worry about it because we are focusing on the Python project today. Okay, so yeah, so it does a lot of things which we can skip. So basically, at the end of the day, this is what the entire architecture looks like. How so there's this guy who is the site admin. He writes the site level configuration file where he specifies different types of information which is needed by the framework. Then the central configuration module, which is the Puppet module in the first implementation, reads this file. It goes to the repositories, fetches all the things like the default meta info.yaml file, default data file, config schema file. It runs your compiler, then it runs the validation engine. Once that is done, it starts copying these component repositories on the infrastructure and then sets up like Kubernetes or Docker Swarm and like the appropriate networking strategy that you need. And then it starts these containers in step 5. And by the end of the day, we'd like to do some tests, which is to make sure everything is in order, which is basically the third part of your GSoC task, which I should have somewhere here, which is basically the test infra part. So once everything has happened, we want to check if everything has actually happened, and that's why we need like the test infra library to go to these all of these machines in the nodes and see if the appropriate specification has been applied or not. Okay. So in the WLCG example, so we are trying to like follow this specification document that you saw on Google Docs and come up with different implementations. So the first implementation which we've been working on at CERN consists of like Docker containers with Docker Swarm as the orchestrator and Puppet as the central configuration manager. And you see repositories for Cream, and torque is basically PBS. So cream and PBS. So that's what you see mostly in the main GitHub organization page. Then there are some parallel efforts. Like last year, we started we started to have like a another implementation which contains Ansible instead of Puppet, and everything else is the same. And then we also started working on another implementation where we had another student visiting to replace Docker Swarm with Kubernetes. And then in the coming months, we'll be adding support for different compute elements and batch systems, specifically the HT Condor ones. Okay. And this is basically summing up what I said. So in conclusion, so Simple provides a robust and so it allows you to set up a robust and complex infrastructure with a small YAML file. And the idea is that you only need to know basic sysadmin know-how Like, okay, what machine am I running on? Are all the hosts properly networked and things like that? And we do not expect our end user to know much about Puppet or Docker or Docker Swarm or anything like that, or even most of like the grid technology. So most of the compute elements are also abstracted from them. Compute elements, batch systems, worker nodes, squids, and so on. There are a lot of things. So we try to abstract as much as possible, but still like a very basic sysadmin know-how is good to know for the end users of the framework. The idea is that you need to focus on your code and your tasks and not on your infrastructure, because with all of these tools which are available today, which were not available back in the day, specifically like Docker, Kubernetes, Puppet, and so on, you can automate a lot of your infrastructure. And if you do it right, you can essentially deploy anything you want really fast. And the project is open source and community driven, and that's why we are in GSoC this year. Yeah. So that concludes like a big overview of why the project came into existence, what are the different parts of it. Some of it you've already seen, and basically the direction that we are going in. Do you guys have any questions so far? Yep, so I'll respond to that GSoC 2019 page and share it. You should already have a version of this specification of this presentation on the HEP software foundation page. I think I did put a link over there. So if I go to WLCG Python introduction to the simple grid framework, I think, yeah. Yeah, that's the link, exactly. But I can also share it with you in the Google group. There's this other presentation from Martin which talks a bit more about the WLCG in general and lightweight sites in general that you could take a look. It's not like absolutely required, but just to because I skipped a lot of details while telling you about the grid and everything, so it covers that in more detail. Okay. So, just to show you, so we recently like did a first deployment uh, at in one of these 170 data centers in Brazil is called CBPF, which is where Heraldo, you'll see him popping on and off around the community and on GitHub. So which is where he's from. So he's a site admin there, and then he recently deployed the framework at his site. And like this graph that I'm showing you is essentially the completed jobs from the physicists around the world. So we started on the 13th, and so far we've done around 240, 238 successful jobs, and that's only running on 5 machines right now, and we'll be scaling up uh, very soon. So all of this happens because the compiler has to work, the validation engine has to work, that Puppet module has to work, and these component repositories that you saw earlier, like the cream thing and the containers described here, have to work. So once all of them work, it's super fast to set up a site and start getting in real workloads working on the like on the LHC data. So just wanted to give you like a sneak peek of like uh, the practicality of the project. Okay. So I think one thing which you can consider your friend for a lot of questions is this specification document. Uh, it's not complete yet, but I think it does describe the compiler in some level of detail that you can make sense of it. And it's also kind of straightforward once you spend some time at looking at the code. We'll be documenting it through the summer. So hopefully by the time you're doing GSoC, you'll have like good documentation available to access. But basically, like this section on the compiler, I think answers a lot of questions about like what we are trying to do. And then if you read it, I think the code might make much more sense. Uh, and the same for the validation engine. Okay. So the link for this is also here. It says specification document early draft. So you've already, so all our repositories are uh, in the lightweight site organization on GitHub. So this contains a lot of Puppet stuff, the Ansible module from last year, and you'll see some more repositories popping up. And this is basically where your contribution area over the summer as well. So I could say like if you guys should really feel free to ask questions, like just use the forum. I've got like a lot of personal emails, but like the advantage of using the forum is that we have a lot of members from the grid community who could also answer your questions or like contribute where needed. So it would be a much better discussion if we use this more. So feel free to do so. Okay, so now moving on to the GSoC part of things. So basically, before April 9th, you're required to submit a proposal. I'll show you an example of a GSoC proposal uh, in a bit. So the idea is the WLCG project is participating with CERN HSF as the umbrella organization, and I think so it's a requirement for us to like give you some tasks that you have to complete in addition to submitting a proposal. So they kind of go hand in hand. And I think it's a good idea as well because you get like some practical experience and a look inside, like under the hood look into all of this theoretical part that we have talked about during the call. So, for the Python project, I think everyone here that we have is interested in the Python project. So we have these three tasks. You guys have already started working on it, which is great. Uh, I think some of the pull requests I got are really good, and I'll merge them as soon as I get a chance. So just keep using GitHub as a communication channel for your pull requests. Uh, you can also send me like a if you want if you prefer not to send a pull request for now, you can also send me like a git patch via email, and I can check that and give you comments as well. That's totally fine if you want to keep your code to yourself during the application period. So this Python project essentially revolves around the compiler, the validation engine, and the infrastructure testing. Uh, so if I can like quickly go to the Python page here and like talk about the scope of the project so you understand what the project is about. So so basically there were a lot of components that needed to be developed in parallel for all of this to work. So we had to skip on a lot of so like TDD is the ideal scenario where we wanted to work, but we could not because of time constraints. So now what we want to incorporate, because it's not too late now, we want to incorporate like a good testing framework for these core components, uh, so that in the future when we make a release, we can do them really fast and be sure we are not breaking things in newer releases as we go. So that's one of the main ideas behind the project. So we want to test the compiler as much as possible in whatever creative manner as possible, so that at the end of the day we are sure that it generates a sensible uh, augmented YAML file at its output. It is super critical that it does that, because if it does not do that, then I can show you I was running a script. Uh, so like one of the containers I was running is complaining. So it's a compiler related issue that needs to be fixed. So essentially, it's the compiler is probably one of the most critical components in the framework. So having fuzz testing or like any creative random testing for it would be great, and that's what we'll try to do during the summer. The next thing is infrastructure validation. So if I go back to the slides again and go back to like this whole big picture that you see. So in basically steps 4 and 5, once we have set up everything through this Puppet module based on the description in this site level configuration file, we want to run test infra on these nodes and make sure that the right containers have started, the right services are running, the right firewall rules were set up, SC Linux is running or not, and a couple of other things. Uh, so in that way, we validate that our after running the framework, the state in which we leave the infrastructure is acceptable. The third part of the project is this config validation engine. So essentially, it's so just to start with the config validation engine. So it basically builds on top of this YAML Python package, and we're gonna make it very complex over the summer. So right now, like the tasks you're doing for GSoC are just like easy, like write a schema. Uh, just talking about, okay, you have to write a schema and then you have to test a particular object. But like if you think about it, we can also like set up our custom data types, which is by data type you essentially mean a schema. And then YAML allows you to combine different schemas together to create more complex schemas. So the concept of data types in this compiler plus validation engine system would essentially come from defining these schemas. So over the summer, we'll be defining schemas or like data types for all these objects that we see, and we can drill down to as much detail as we want. Once we have like these schema slash data types, we can write validation rules for them using YAML. So YAML basically provides us a connection between the schema and the validator code. So we take advantage of that and then just write our validators to check if the correct values were provided over the summer. So these are very basic validators. But like if we jump into the lightweight component section, so guys, whoever is trying to go for the, I think I removed it from GSoC. So this is like a pretty complicated thing. So this is better done in the summer and not now as one of your tasks. So like things here can get kind of like pretty complicated based on the schema. It can vary a lot. Uh, so the validator written for lightweight components has to be, for example, pretty smart, which we'll do during the summer. But essentially, if you go through the site level config file, uh, like in your head, so once you like if you've already started working on the validation engine, you already will have some idea about how to declare these data types slash schemas. And then at the end of the day, we are just trying to get a one full detailed schema which can validate this entire file. Uh, so that's one of the goals of this Python project in GSoC. And through these issues that we have in the validation engine, we are just targeting some small sections of it. So like the worms config object, which is somewhere here. Okay, so during GSoC, we'll try to come up with one consolidated schema file. Yeah. So why that's necessary, like if you're trying to relate it back to the presentation, is that right now the repositories have their schema, which I can also quickly show you. So for example, the CE cream over here has its schema, which is kind of built on top of the YAML schema. So you'll see the same validators over here. Uh, But if we want to use this framework out in like in multiple scenarios, which could be multiple grid scenarios or like scenarios like the ones I mentioned in finance or other things. So in those scenarios, maybe you do not need this worms config thing or anything else. So we want to make sure we have like a way to define a schema for the site level configuration file directly so that you can have different formats of site level configuration file for different use cases, and we can check that. Does it make sense? Okay. Okay, so that's basically the idea of the GSoC project. We're going to be breaking a lot of things. That's the goal. The more we break, the better it is. So the idea is to break the compiler, break this validation engine, and also develop it in parallel, and break all the machines that we set up with using like on which we set up a grid site. So we'll see how that goes. How does the project sound, guys? Think you think it's too complicated, too easy, too challenging, or something? Because based on how you feel, we can still tweak things a bit and make it more appropriate for the summer. Okay, cool. All right, so that's the idea of the of the project of the Python project. So now there are two things you have to do, the tasks. I can discuss the tasks a bit, although I know all three of you have already started working on them. So for task one and task two, the idea is you just have to send one pull request. Don't worry if it is not merged. We are not trying to make your code part of the release right now, but we'll do it as soon as possible. So just for GSoC, you need a pull request, and if you can incorporate some of the reviews uh, that we suggest, that's more than enough. And you just have to pick like one task, one issue in both of the repositories and work on it. So that way we know that you're familiar with the Git workflow, you have been able to set up your development environment properly and run these like the compiler and the validation engine locally. So that's basically what we are trying to look for. And then the PR already gives us some insight into like the code habits and things like that that you follow. So that should be enough. So just working on one issue for task one and one issue for task two is all you need as a task uh, for your GSoC proposal. The third one requires you to set up the dev kit. So if you have problems, so like I think Parth said he had a problem setting it up. Do get in touch immediately so we can help resolve it. So it's not a very it's kind of a different kind of a task. So we do not want you to waste time on setting things up, but we want you to focus more on like completing the task So if you have trouble setting things up, let me know and we can try to resolve it. Okay. And like if nothing works, then I think the best way is go to Amazon AWS, get a free VM, which is completely clean, set up Docker, complete your task, and then we can resolve all the other issues later. Okay. Uh, so yeah. Okay. So those are the tasks. Feel free to use the forum to ask questions about them. The next thing, which is the important thing, is the proposal. So I've posted this like GSoC 2019 proposal template that you can follow. So I'll show you an example of the proposal. So essentially, one thing which I want to highlight is you have to come up with like this proposed timeline for yourself. So in this timeline, you basically describe that, okay, in the community bonding period in early May, when I get selected, I'm going to set up dev environment and tools, uh, and communication channels, check out documentation required to like do your project better. Maybe work on a little bit of issues like the pending GSoC issues, the smaller ones, to get warmed up a bit about the project. And if you want, I could actually like help you set up a small data center using the dev kit so you can see things working for yourself. But do not mention that in your proposal. It would be just like a fun side thing to do. Okay, then you need to highlight everything you do in like week one, week two, week three, week four, during these dates. So you can break down things into different tasks. So for example, let's say the first 2 weeks you say, I would like to like complete basic testing of the compiler, just unit tests. Uh, then you could say, okay, I want to spend like the next week doing some fuzz testing or random testing for certain functions which seem appropriate for that kind of testing. Or I want to do some integration testing to see how different phases work with each other. So, like earlier in the call, I discussed a potential unit slash integration test example for this semantics function that we have in the compiler. Uh, and then you basically keep going on, try to cover all these three tasks, estimate how much time you need for all of this. So by the time you write your proposal, you would have already touched test infra, the validation engine, and the compiler. And I've discussed about like the scope of the project earlier here. So you can have like a mental timeline. Okay, this much time is what I need to do, blah. This much time is what I need to do, blah. You might need more time for the test infra thing. Uh, so that will require like some discussion on our end, which we can do during this call a little bit, so it can help you like while you're writing your proposal. Uh, so basically, you have to fit in all of your tasks in a weekly manner in this timeline. And one important thing is that you need to leave enough room for towards the end for documentation. That's a requirement for Google Summer of Code. And you need some time for like bug fixing or like small improvements that you did not get a chance to do during the week. So I think the last 2 weeks should be mostly around documentation, testing, bug fixing, and things like that. Okay. So when you write a proposal, feel free to use like diagrams, maybe from the slides or like anything that you think can explain better what you're trying to do during the summer. If you have questions about like how things are working in the framework, how things are working in the compiler or validation engine, or about the test infra thing, send an email or like we can start a discussion on the forum so more people can jump in and you have more information that way to work on while you write your proposal. In addition to the proposal, like there are these basic questions about like who you are, what you're doing, and your past experience, and some link to your GitHub page and things like that. Uh, that you should include in the proposal. Another important thing is like if so because you're students, you'll have exams or you'll have like holidays or vacations or travel, classes or whatever. So do make sure you include them in the timeline and explicitly mention them in your proposal, so that we know how much time we have to work with. And then there are no surprises during the summer regarding that. Okay. So this is like a proposal from what 2016. So I've been a Google Summer of Code student twice in my life, and like I used to write like really detailed proposals. So so these are just like the basic questions that I told you, where you can describe about your old projects and things that you've done in the past and your links to your like works and certifications and things like that. Uh, Holy shit, that's big. Okay. So then you can start with describing the project. So this is a part where I say over here, uh, you must describe how you plan to approach the project. So in this proposal, for example, I highlighted how I would approach the project where I gave. So this was basically a web-based project where we had to create several OAuth 2 compatibility endpoints for this organization called OpenMRS. So I kind of like gave them a pretty detailed specification of like these are the endpoints, these are the parameters that these endpoint needs, and described them a bit of why they need to be there and why some things do not need to be there or could be up for discussion, and gave some use case diagrams. So this was what I meant by like adding diagrams that explain things better. So here I gave some diagrams about like different flows in the OAuth 2 protocol and how it would work with their particular system. And then the project was also another task in the project was like integration of things into something called Smart OAuth to healthcare apps, which I describe in a bit on how to go about it. And then this is like the timeline. So this is the way I've seen it done several times, and I did it myself both times I was a GSoC student. Uh, like I had very concrete action points of like what needs to be done and how it's going to be done. So you don't. So one thing is, do not pressure yourself into thinking like this is going to be exactly your plan of action, because like once you are selected, we'll go through this together and try to come up with a more strategic plan of action. So this is something which you propose from your side that you could do. But once you're selected, we'll definitely get back to it and try to go back and forth and agree upon a timeline among ourselves. So then there was this section about deliverables and anticipated challenges. Uh, I think we should include it. If you include it in your proposal, I think that would be good, but it's not a absolute requirement. But essentially, like this is kind of a pretty big proposal. You don't have to go this big. I would say use just sufficient pages that you feel are enough to explain everything that you're trying to do during the summer, things that you will deliver during the summer, you feel things that you feel are going to be anticipated challenges, basic questions about you, and a timeline, and some insight into your understanding of the project, which is where you'll describe the tasks and how you're trying to do them. Does that make sense, guys? Okay. So I would say like okay, so you can start writing your proposals, and you can, whenever you have like a early draft, you can submit it as a draft and ask for like me and Martin for reviews. So the way it works is like once you submit your proposal, you can still modify it and like upload a updated version of it, and the mentors can leave comments on where you can improve. So I think that's a pretty helpful process. So if you can do it a couple of times before April 9th, we can really ensure that you have a super strong proposal. And that's one of the most important goals before April 9, to make sure like all the proposals that you guys make are in a good enough shape. Internally, I think the organizations get only a fixed number of slots from Google. So in order to make sure that we can get a slot for the Python project, we need to make sure we have really good proposals. So I'd encourage you to do a couple of iterations of that. Do not like wait for the last week or the last days to do that. Like you could start doing it right now parallelly along with your tasks. Uh, and yeah, and like submit as soon as you have a early draft. Okay. So I think that's all I wanted to discuss over this call with you guys. So if you have any questions or any other discussion points, we can do that now. Yeah. Yeah, that's the thing. So we are stuck on 2.7 right now, and there's a reason behind it. So we'll be using Python 2.7 for another year or so, because a lot of these data centers or grid sites are using CentOS 6, and CentOS 6 uses Python 2.7. Therefore, we need to provide something in Python 2.7 for them. But yeah, but like we also have to keep in mind as we develop this over the summer that we would have to move to Python 3 pretty soon, like in another 1.5 years or 2 years, when SLC 6 is end of life. So we should try to not use anything which is too heavily dependent on 2.7, so that if we make a migration, it's like, oh, we have to refactor a lot of code. So that's another thing to keep in mind. Okay. Anything else, guys? Okay. You can say no and unmute your microphone so I know. Okay. Okay, great. So yeah, thanks for joining the call then. Good luck. Keep sending your pull requests whenever you're done, and keep submitting your tasks. Uh, we would really like to help you out as much as possible with your proposals and your tasks. So remember to submit early. If you need any more information about anything, just use any of the communication channels. I would highly encourage you to use the Google group to reach a much wider community. And good luck. If you have any more questions, just reply to this message here. Like, where did it go? Like this GSoC 2019 office hours thing. You can reply to it and say that you want to attend the next one. So I'll be online during the next one then, and you can ask more questions on Saturday. Okay. Yeah, thank you for joining the call. Sure. All right, guys. Yeah, thanks again. It was a good discussion. I described a lot of things. I hope you got like you it was a lot of information, I know, so like I'll let you take your time to understand this bigger picture. But I think the part about like getting your proposal done and getting your task done, I hope is clear. So just focus on that as much as possible right now. And good luck. And see you on Saturday if you have anything more to discuss. Okay, sure. Okay, bye bye.